All right, so these are the combination circuits. This is what happens when you have a series and a parallel happening at the same time. As you can see, we have two branches, which feel like parallel, like yesterday, but inside this branch, we have two resistors that are in a straight line. So I call these series inside, because the inside branches are series. I'm gonna show you how to solve one. The other one we're gonna also look at is parallel inside. It's the opposite. Essentially, you have to use Ohm's law, your series rules, and your parallel rules at the same time. So when looking at this circuit, we have a 12-volt battery attached to four 2-ohm resistors. These two are wired in series, but they're in parallel to each other. So we call this branch A and this branch B, and it kind of acts like a parallel circuit when you're looking at the bigger circuit, but inside those branches, you have some series rules you have to abide by. Make sure I'm still lined up. Yep, okay. So we have this 12 volts, there's your 12, and then we're gonna have all four of our resistors. We can call them 1, 2, 3, 4, it doesn't really matter. They're all 2. So all of our resistors are 2. Those are your givens. Now when you go to solve this, you're going to use both sets of your equations on your formula sheet, series and parallel. Let's start with branch A. Branch A is in series, and if you look at your series rules, you're going to add these two resistors. 2 plus 2 gives us the 4. So the whole branch is resolved into a 4-ohm resistor. For branch B, that is the same thing. 2 plus 2 gives us 4. Beautiful. Now, A and B are in parallel as a branch right here, as we saw yesterday. We know the whole branch is 4 for both of them. We're gonna add them as if they're parallel circuits now. So that's where you get the 1/4 plus 1/4, right here. 1/4 plus 1/4 gives us 2/4. But remember, we have to flip that fraction. It's gonna be 4/2. So for the whole circuit, A and B, the total resistance is gonna be the inverse of that, 4/2. So our total resistance is 2. Now we can use Ohm's law. As always, if we have 2 of them, we have all 3 of them. 12/2 is 6. All right, well, where do we go from there? We have all these other voltages and currents to fill out. A and B are in parallel, and if you recall, voltage is equivalent in a parallel circuit. So A and B is getting all 12 volts of that battery. And again, Ohm's law will give us those currents. 12/4 is 3. 12/4 is 3. And now we look on the inside. Inside the branch again is series. It means if this current for the whole branch is 3, that means each of these resistors is getting 3 ohms. Same thing for over here. Inside this branch, the whole thing is 3. It means each of these resistors, because the series rules told us the currents were all equal. And finally, we use Ohm's law. 3 times 2 gives us that 6. 3 times 2 gives us that 6. 6, 6. Now it also adds up the voltages like we saw on Wednesday. 6 plus 6 gives us that 12. 6 plus 6 gives us that 12. Now this is a very simplified version of this circuit. You will use factors of 12. They're all very easy to add and do in your head. But what you really want to focus on is where are the patterns, right? Where are the things the same and where are they being added up? Obviously, you're going to build this thing and you're going to test voltage and current and calculate resistance, but it should match this pattern. And I'll have this sheet on the board so you can come back and refer to it as a reference. You're looking at what is the same and what is different, right? Where is it additive? You will need to build this circuit quite large so you can get into this branch and measure all those currents and measure all those voltages. Obviously, we've had a lot of work with that this week. So do give yourself room for that. Now we're gonna look at the opposite circuit, is what happens when you have parallel inside. It is the same battery source, 12 volts, 4 2 ohm resistors, but now the big circuit is in series, but you have these little branches where you have 2 resistors that are in parallel, because you have a branch right here, and they come back together, and then it splits off again. So we have 2 parallel circuits that are in one big line. So we call this one parallel inside. Make sure we're still framed up and good, all right. So to solve it is a very similar process. We have our total voltage is 12, and then we have all 4 of our resistors that are 2. Now we're gonna do the same thing. We're gonna find that resistance for the branch. We call this branch A up here, and this could be branch B. It's kind of arbitrary, you just pick a point. Now for branch A, they're in parallel, and for parallel resistors, we add their reciprocals. So a half plus a half is a whole. We want the inverse of that, so 1 over 1. It's just gonna be 1, right? 1/2, it's 1 over 1. Take the reciprocal, you just get 1. Same thing for the other guy, 1/2 plus a half is that 1. Take the reciprocal, you're gonna get 1. A and B are, I lost my shot. A and B are in series. We now know the resistance for all of A is 1, all of B is 1. Outside the circuit is in series, so we're gonna add those resistors together, 1 plus 1, and we do indeed get 2. Ohm's law tells us what this current's gonna be for the whole circuit. This is the total line. 12 over 2 is 6. Now the outside is in series, so it means A and B and the total all have to be the same on the current line. That's what we were practicing on Wednesday. So all these guys are 6. Again, Ohm's law will give us that voltage. 6 times 1, 6 times 1. And looking back into the branch, right, the whole branch is 6. This whole branch is 6 on the voltage. But because they're parallel, both of these resistors are getting those 6 volts. Right, now I had all the same resistors, so all my numbers are very symmetric. If you had made it 4 and 4, you would see a difference. But I'm keeping it very simple. This is a complex circuit. Again, Ohm's law will finish us off here. 6 over 2 is 3. 6 over 2 is 3. 6 divided by 2 is 3. Again, I'm just using Ohm's law. 6 over 2 is 3. Now these currents do add up to our total, which is what series told us. And we're good to go. So the goal here is you're going to also build this circuit, and you're going to look for where are things additive and where are they the same, right? 3 plus 3 is 6. All our voltages were the same. Again, you want to build these circuits wide enough, give yourself wide enough lane so you can break it anywhere you need to measure current or measure the voltage. Voltage, again, is easy. You're just going over the top of the resistors. Current is where you got to get inside that circuit and build it effectively so you can break it in the right spots. You probably need 2 battery packs for this one. This will be our final circuit. You will be building both. Again, I'll have both these sheets on the board so you can refer back to where the patterns are, where they're the same, and where they are different.